Hi, this is Sam Grun with Siemens PRM Software. Today what we're going to cover is the new functionality within the NX10. What we have here is a NX layout. In this a simple illustration, what we have is we have three geometry. In this case I will have a piston and a crank and a link. What we have already done is we have already preconditioned by applying assembly constraints and applying a group within this particular sketch. And then these individual are defined already. Now what we want to do is define the 2D component for the NX layout. By grabbing each one of these individual geometry within that particular group, we could quickly define the information of that. And then what we're going to is just go and select the second one, in this case, which we're going to call that to be the link. And then we're going to drag and highlight that, and then we're going to get this particular information. The window that pops up basically says all of our constraints will be pushed into our 2D components as well. So we'll dismiss that and continue on to our third one, which is the piston. Now once we define that location of the link, we want to go ahead and define the name of the pistons. Just quickly do an image capture of that. So now we have the three components within this particular sketch. We can go ahead and remove those folders that contain zero information now. Now what we want to do is we want to go ahead and create the assembly from these components. We can quickly push that out. Once that is done, we maximize the screen space. So now we see that we have three components within this top level assembly. Next thing what we want to do is just simple information. Just use grab onto the sketch and then just create a revolve of this particular piston. And then when that is done, what I want to do is just go ahead and punch a hole through the middle where the link will be able to mount to this particular piston. So quickly we define a front to value, or we can just go ahead and do a select to a particular face. We can do it either way. But nevertheless, we can quickly create this piston from the 2D layout. The next thing we want to do is just go and work on a particular link. Same principle. In this case, instead of doing revolve, we just do a simple extrude. Grabbing onto the sketch, we can take a certain distance. Obviously, this the thick of this particular link will be thicker, or with a width, be able to grab onto this particular piston. In the middle of the part, we want to go ahead and open that up so we can be able to grab onto the piston and also accommodate for the crank on the back end as well. When that is done, obviously a lot of times we want to do certain things to reduce the weight. We just want to punch a hole through the middle. When that is done, we just now just quickly create the blends at each one of these locations, so the transition of the load will be much easier, will not cause any stress concentration factor at the corners. When that is done, now the next thing we want to do is just go in there, just change the color, just easily define which one of these components are listed on the display. The last thing we'll want to do is to be able to work on the crank. So a lot of this work that we're doing is we're doing what's called design context. Basically, it's just to create something that within that from the sketch that we push out from a 2D layout. So this type of workflow is that we made that available from a very simple 2D geometry. We can be able to take advantage of that and then push that information down into the 3D environment. So this concludes our demonstration. Thank you.